So, we're going to start off by going back over how to solve algebraic equations. We're going to start off with the easy stuff, just linear equations. Really, it's just one x, and we're trying to get that x isolated so we can figure out what numbers that I use to make this true. Maybe it's one answer, maybe it's two answers. Okay, when it's linear, I'm only going to get one answer. If it was quadratic or cubic or anything different like that, the number for the exponent, we call the degree, is going to tell me you may have two answers. You may have three answers. Depends on whatever the degree is. And so I want you to solve this. And the way I kind of work class is I want you to try it first. If you can't figure it out, ask your neighbor. Okay? And then at the very end, if you guys can't figure it out together, then I'll go through it on the screen. If you have questions, raise your hand. I'll come by, give you some tips. But this is pretty straightforward. Yes, you may have fractions as answers. Leave them as fractions. I mean, you could have a decimal too, but I'd rather keep the fraction. You see? All right, here we go. First thing we're going to do is what? What do we call that?
FOIL.
Nope. Right here. What do we do from here to here?
Multiply.
Distribute. It's multiplication, but yeah, we're distributing. So, in order for me to get to the x, I have to get rid of those parentheses. I've got to get all the x's together into one spot. Then I can find out what the x is going to be. What would the next step be? Combine like terms. Now, this is really important. What makes something alike? Two things. Same variable and same exponent. In this case, how many different kinds of terms do we have in this expression?
Two.
Only two. The terms with x and the terms that are just constant values without x. Okay, they're not ever going to change. All right, so if we go ahead and combine like terms, okay, we did one this way. I combined it on each side, although you can do a couple things together. And so your answer should end up being 5 halves. Okay? 5 halves or 2.5. I don't really care. I will almost always stay in fractions. Some of you are terrified of fractions, and you're just going to have to get beyond that. Because we're going to have a lot of fractions this year. Not just like number fractions, but like expressions with sine, cosine, tangent, and all this other nastiness that you're just going to have to get used to. So,
Just a couple problems.
We'll see. Example 2. Speaking of fractions, let's do one, shall we? And you shouldn't need any calculators for any of this. So we have, first of all, we have 1, we have 2, and we have 3 pieces. Terms are separated by plus signs and minus signs and equal signs. Right? So we got all these pieces to put together. I want to get these pieces, these two parts, together. And so if we kind of put them on one side, it looked like this. I just subtracted the y over 4 from this side and that side. Whatever you do to one side of an equation, you have to do to the same to the other side. If it's equal, then if I manipulate something, if I take away something from one, I have to do the same thing, or they're not equal anymore, and you just made a false statement. Or your answer won't be the right one whenever you get down to it. Now, you could proceed here in 2 methods. One method is quicker than the other, but I don't think one is more correct than the other. Probably most of you think I need to get a common denominator so I can add the fractions. That's the most common answer. And what is my common denominator? 8. So which fraction would we need to manipulate? This one. This one already has an 8, so we're good. If I multiply that by 2 and the top by 2, I would get 2y over 8. And then I could combine the tops. But let me stop you for a minute. How about I say that you could go from here, and I'd rather not have any fractions after this point, period. Once you find a common denominator, which is going to be 8, right? How about we multiply every fraction by 8?
Why would you? If you feel it.
Why don't you? Well, this is what would happen. If you went in there and you multiplied each fraction by 8, remember, whatever I do to one side, I have to do the other side. So I multiply everything by 8. So I'm being equal across the board. What would happen to that first fraction? The 8's would cancel. So you're left with just 5y minus 2. What would happen to the second fraction? Yeah, the 8 cancels with a 4, but so it cancels out with a 2. So you have 2y equals 8 times 2, which is 16. No fractions. Piece of cake from here. Okay. Shh. Oh, yeah? What's 8 over 4? There you go. Shh. Shh. Good, very good question. Okay? He says, how can you, the question was here, look, how can you multiply 8 times this fraction and it be equal to this? Okay? Legitimate question. So it'd be like this, 8 times y over 4, right? How do you write a whole number as a fraction?
8 over 1.
8 over 1. How do we multiply fractions, Devin? Straight across. So what's 8 times y?
8.
And 1 times 4? Okay, same thing. Does that make sense? Tracking with me? Okay. You'll need this later on, this technique, to make things easier for you. So how would we finish this out? Combine like terms. We're back into what we did at the beginning. So once you clear your fractions, it becomes something basic. Just combine like terms, get the y by itself, divide, if you have to. Right? So if we finish that one out, oops, wrote over myself. There it is. Y, if you combine the 5y and the negative 2y, that gives us 3y. And I added 2 to both sides to get the 18, then we divided by 3 to get 6.
I got that answer by the way.
How'd you do it? Did you common denominator?
I just multiply 8 to the other side. Like in the beginning, I just multiply 8 with 2. And that's
That's okay. That's okay. That's almost like what we did here. Just different order.
First part, you only multiplied the 8 by the 4.
Where?
The first term.
I did 5.
5 times.
No, I did 5. The 8 on the front one canceled out with the 8 on the bottom of the fraction. That's why nothing changed on the top. Questions about this one?
No.
That is a really helpful tool because you're going to have fractions. Let's try another one. What's an inequality? Shh. What's an inequality?
Greater than, less than, or equal to, something like that.
The equation that uses
Answer is yes. Okay. Inequality is, what's the difference between an equation and an inequality? You don't get an exact answer in an inequality. Very, very true. An equation has an equal sign. An inequality has a greater than or less than or equal to, whatever. Okay. So this is what an inequality would look like. Do I treat an inequality any differently when I'm solving it than an equation? Not entirely. There's only one thing you have to worry about. When the sign flips, what happens to make my sign flip around? It's when I multiply or divide by a negative number. If I do that to both sides of an equation, I've got to flip that inequality over. Solve this one. Okay, so when we worked this one out, the things we did, we took here, we said let's distribute the first part. And I got this. So 3 times x, 3 times negative 1 gives me this part. Everything else remained the same. Now, next, there's no exponents, there's no parentheses. so I don't have to do any of that extra stuff. I'm going to go ahead and I'm going to get together everything that's alike. So that means the things with x need to get together. The things without an x need to get together. And so if you look at it, you have two terms that have a variable. So if we subtract, basically we're going to say subtract 3x, both sides. And that's what gives me the 2x. It's 5x minus 3x is 2x. You may not ever combine a 5x and a 4. If I said subtract 5x minus 4, your answer is just 5x minus 4 because those two things are completely different. They can't combine. They can't be put together. Okay. The other parts we did, you had a negative 3, a positive 2, and a positive 6. So, I want to get them away. Since I put the x on the right side, I want to get these on the left side. So what's negative 3 plus 2?
Negative 1.
What's the rule about combining opposite signed numbers? What's the rule? What's the mental math rule? No? If the signs are opposite, in other words, I got a negative number and a positive number. The question is, what's the mental math procedure? If the signs are opposite, subtract. So it's a negative 3 and a positive 2, right? So what's 3 minus 2? Which number is bigger? So you keep the sign of the bigger number. So it's negative 1. If the signs are opposite, subtract them, keep the sign of the bigger number. So I've got a negative 1 and it's positive 6. So if we write this out, that would end up being 3x minus 1 is less than or equal to 5x plus 6. If I'm going to get the whole numbers together, what am I going to do? We subtracted the 3x we said earlier. I'm going to subtract the 6. So that's gone here. That leaves me with a 2x, and this would leave me with negative 7. If the signs are the same, add the numbers together and keep the sign. Does that make sense? Questions?
I'm good. I got it.
Okay. Answer. When you put in a number line, now put two ways. You don't have to do both. Some people use brackets and parentheses. Some people use open circles and closed circles or filled in circles. I don't really care which way. Okay, I tend more to write on the number line with the bracket or the parentheses. But if you use an open circle or a closed circle, I get the same. You do whatever you're comfortable with. I don't really make a preference. I may ask you for an answer that's put it on a number line. Okay? If you read that statement, it says we typically want to have x on the left side. So if I take that inequality and I flip it around, that says x is greater than or equal to negative 7 halves. So find negative 7 halves, which is just negative 3.5. I put a closed point there, or a bracket, and it's greater than that number. So greater than is always going to the right. Less than is always going to the left. No?
Yeah.
Okay. If you put it like this, the inequality points in the direction that you should shade. Okay? This one is backwards. Okay? If you look at it like this, we don't want to go on that because that's pointing this direction. X needs to be on the left side before you can use that idea. Or just say it to yourself. X is greater than this number. Greater than means positive numbers. Less than means negative numbers. Keep that in mind. Questions? We good? Let's see. I need to erase something. Okay, here we go. Next one.
Mr. Wig, do we go directly to the gym after this? Or do we go to second?
Inequalities with fractions. Try this one. All right, so if we clear our fractions, okay, which was my hint, try clearing fractions, you should end up with that. If you just got a common denominator, what you're going to notice is that that's the same thing you have, except you have denominators. Okay? And so you can go with it this way, and now I don't have to worry about finishing it up. What's my solution?
I just did that wrong.
And this one's nice because really when I subtract 3x on both sides, I just have x. And when I subtract 6 on both sides, I end up with -2. So that was a real quick one. Looks kind of bad with all the fractions, but it's not. Don't let the fractions freak you out because they're not that bad.
So it's okay if you kept them outside.
If you did the common denominator method, that's great too. You should end up with the exact same solution, just maybe in a couple of steps. Questions? Devin, you good? Yeah? Okay.
Since I got it the other way, a -2 is less than. You wish it-
-2 is less than x.
Yeah.
So if I say it the other way around, x is greater than -2 means exactly the same thing.
And you just shade it to the other side.
No.
Just pass it.
No.
You leave the circle open?
Yes. Why do we leave the circle open?
Because it's not equal to.
Because it's just a greater than statement. If it had been greater than or equal to, then we would have the circle filled in, or we would have the. Notice this here. Notice the part here. That's a parenthesis, not a bracket. The one we had before that was a square bracket. This means not equal to, just like the open circle here. Okay, if you used a bracket, okay, if you're used to using circles and open circles, brackets or parentheses, I don't really care. Just pick one and go with it. Questions on that one? That was a pretty straightforward one.
This parentheses like open circle and a bracket.
Parentheses is open circle, bracket, closed circle. Let's try that one. This one's called a compound inequality. It means there's two at the same time. So let me give you one tip. When you have a compound inequality, rather than having the left and right side of an equation, you now have three sides. You have left, center, and right. Nothing has changed. What you do to one part, you do to all the parts. Okay? So there's three parts. To do all of them the same way. So try this one. See what you can do with it. Watch. If we take this apart, what I want to do, what really interests me is if I notice the fraction in the middle, or if I had a fraction in any of the parts, I really want to get that, because that's where my x is, so I really want to undo that part. What is it when you have the fraction and a number at the bottom? That's dividing by 3, right? We need to get rid of that, so we undo the division. What is the opposite of division?
Multiplication.
Multiplication. So we are going to multiply all across the board by 3. And so what you see, and you can see that down here, if we do the 3 times -3, that gives us -9. This 3 cancels with that 3, and that's kind of why I wanted to do this, to give us just what's in the middle here. And then 3 times 5 is 15. Now I have a traditional inequality. Remember, I'm trying to isolate x. Right, Devin? So we're going to work this just like we would any other equation, except now I have two parts. I got to add it to both sides. Right? So what do you think the next step would be?
Subtract 5
From where?
to both sides.
From both places. So subtract 5 from the 15 and subtract 5 from the -9. It's kind of like having two equations at the same time. That's all there really is. Nothing fancy yet. This falls down at least twice a day. Yeah, put some better sticky tape. I didn't put it up there. Not my sticky tape. All right, so the next part we would get would look like this. We good? And then what would we do?
Divide everything by 2.
Divide everything by 2. I'm done. Notice. The x is between -7 and +5. So I shaded between those two numbers. One of them has an equal to, one of them does not. So I put down the different varieties that you can do. So if we have an equal to, then it gets a solid dot or a bracket, a square bracket. The not equal to part, just the less than, gets an open circle or a parenthesis. And I shaded in between, or I just drew a line between the two above the number line. Either, remember, you don't need to do both of those. I was just showing you both ways. Some people have done it one way, and you can continue to do it that way. It's okay. Questions? You're good? Let's see.